Recording in progress.
All right, I think we cool. Just give me 1 second. Yeah. Absolutely. One second. Hi. Hello. Okay. So, any questions? I mean, you can ask some now too. I'm open. Let's see what you got. 9x squared minus 6x plus 3 plus 1. Just factor it? Okay. So just looking at this, there's no GCF, right? So the only thing that's popping in my head is the AC method, right? So what's my A here? 9, good. What's my B? -6. What's my C? 1, right? So I'm thinking about A times C, which is equal to 9 times 1, which is equal to 9, right? And then my B term is -6. So now I want two numbers that when I multiply them together, I'll get +9. When I add them together, it'll give me a -6. What are they? 3. 3 times 3, all right? But -3, right? So -3 times -3, that's the +9. -3 plus the -3, right? That's the -6, right? All right. So now that I know what these numbers are, right? I can rewrite my question that I have here, right? Keep the first term. So I have 9x squared, but instead of the -6x, I'm going to have -3x and then -3x, and then bring down the last term, which is the 1. Just like that. So now I have 4 terms, right? So now factor by grouping, right? I have a left group and a right group. On my left group, I want the greatest common factor, which is what? 3 what? 3x, right? So now what's left over? Remember, it's like you're dividing by 3x. So you're dividing by 3x, right? So what do you have? 3x. A negative divided by positive is a negative, and 3x divided by 3x is 1. Very good. What about the second group on the right? So, not 1. What is it? Greatest common factor? No. No. You're getting closer. No. No. It's a combination of what you said and you said. What do they have in common? What is it? -1. That's it, right? Because the sign of my leading coefficient is the sign of my factor, right? So -1. And then what's left over? Remember, it's like you're divided by -1, divided by -1. So I have 3x. No, positive by negative is a negative, and 1, right? Now, after I get this, greatest common factor one more time, I have the 3x minus 1, and then I have the 3x minus 1. So you can enter that as your answer in WebWork, or sometimes they might have a question where they want to see this one, 3x minus 1, and then like raised to the second power. So I'm not sure which one they want, but they might want one of those. Sure. Gotcha. Now we could have used a shortcut on this, but It's all right if you don't want to. AC method works for every single question. Not yet, not yet. Hold on. All right, go ahead. So just factor it? All right, so what's the answer, tell me? So 5 what? 5x, good. Minus what? No. No. 2, good. And what's the other one? 5x plus 2, very good. Right? That's the difference of two perfect squares. Good job.
Are you going to specify the test of what we know? Either 5x squared?
Oh, if you give me either way, I'll give you points. Yeah. Like whatever you're most comfortable with.
Or
That's not bad. What's the answer? All right, so 2 and 2. And what else? 3 what? 3 what? 3y. Good, good, good. And what are the signs? That's it. Done. Anybody else any questions? Okay, 36x squared. I got you. That's it? All right. That's not bad. What's the answer? 6x, good. What else? Mm-hmm. That's what? 7y. And then minus 7y. Very good. So you see the 36x squared, right? That gets broken down to 6x squared. And the 49y squared can get broken down to 7y squared. And that's where these numbers are coming from. You know? So you just plug them in with a plus or a minus, right? But remember, you're only allowed to do this if the original question has a minus in it. If the original question is a plus, we can't do this. Hold on 1 second. Let's see, get your question. Hmm? Plus 7x? Okay. Plus 5? Like that? All right, so for this one, right, just do long division, right? So you got the 2x squared, right, plus 5. And then I'm just going to put everything else in numerator down here. 2x cubed minus 16x squared plus 7x minus 32. And then just go about doing it, right? So 2x squared goes into 2x cubed how many times? 2x. Not 2x. Not one time. I mean, yeah, one time, but no, that's not what I'm looking for. 1x goes in x times, right? And then x times 2x squared is what? 2x cubed. And then x times 5, what's that? That's 5x. Right? And then what we're going to do, this is going to be plus 0x squared here, by the way. So then what am I going to do? I'm going to subtract these. Just like that, right? So 2x cubed, that cancels out, nothing I can do there. Negative 16x² minus 0x² is negative 16x², right? Then we're just gonna bring this down, 7x minus 5x plus 2x. Just like that, right? Now, 2x, no, I'm gonna get to that later, yeah. The 2x², right? That goes into a negative 16x², how many times? 8 times, okay. Is it just 8? Not 8x. Something else I'm looking for. I want to go from 2 to negative 16. So what do I multiply that by? Negative 8. Negative 8, right? So negative 8 times 2, that's the negative 16x². Negative 8 times 5, what is that? 25, 30, 35, it's 40, right? So I think that's like what, negative 40? And then now, what do we want to do? I want to subtract this, right? So 16x² minus negative 16x² cancels out. And then we're going to have what? 2x minus, this should be plus 0x right here, is going to be what? 2x again, right? And then I have negative 32 minus negative 40 becomes what? Positive 8. Very good, right? And then that's it. That can't go in. So my final answer would be the x minus 8, right? Numerator will be the remainder, which is 2x plus 8, divided by the denominator, which is 2x² plus 5. And that's it. That little part right there. I'm not sure what the question is asking, if they just want the quotient or if they want the quotient with the remainder or something like, yeah. So the quotient is the x minus 8. The remainder is a 2x plus 8. What?
X, or
That's it? All right. So what's the answer here? Okay, there's a 9 here and a 9 here. Good. What else? Well, x to what power? Good. Same thing here. What are the signs? Good. Now you know I'm not done, right? Because I can factor out the difference of two perfect squares, the ones with a minus. So what does this one over here become? So I'm looking specifically at this first one right here. It's for its first term. What does that become? X minus 3. And what's the other one? Very good. Now, that's the end of the question. You put in all three of them? You have to let me see. What? X squared what? Like that?
Yeah. Plus 16y².
Like that?
Yes.
All right. So what's the answer?
X
If I have an X and an X. So I heard a plus. And a plus, right? For what? No, for what? For Y. Good. That's it.
But it said, it does not match.
Something could be wrong with the middle of it. Alright, it happens. So, bro. Alright, not sure.
You're not sure.
Yeah, because this works. The only thing I think is parenthesis there's like an extra parenthesis there. That's the only issue.
Oh, yeah, right.
There's an extra parenthesis in there.
Oh.
Yeah. One little parenthesis. Mm-hmm.
Times X divided by second time 2x times 1.
Like that? Okay.
Oh, so it's
Cool.
positive. Positive.
Good. All right. Yeah. I mean, I could do what you call it. I could factor it and then knock out the like terms, but long division is easier way. So let's see. I have x squared plus 2x plus 1. Over here I have x cubed plus 0, x squared plus x plus 0. All right? Just to make it more expanded, you know?
What is the 0 adding 2?
Yeah. I'm not really adding nothing to it. It's 0, you know? So anyway, x squared goes in x cubed how many times? X times, right? And then x times x squared is x cubed. X times 2x, what is that? Plus 2x squared, right? And then x times 1, what is that? Plus x. And then I want to subtract these. So x cubed minus x cubed cancels out. 0 minus 2x squared is negative 2x squared. And then x minus x is, what's x minus x? Oh, they cancel out, right? So 0x. All right. Okay. And then after that, I guess you could just bring down the 0. So x squared goes into negative 2x squared how many times? Negative 2. And then negative 2 times x squared, that's a negative 2x squared. And then negative 2 times 4x is what? That's a negative 4x. And negative 2 times 1 is a negative 2. And then remember what I want to do? I want to subtract these. So negative 2x squared minus negative 2x squared, that cancels out. 0 minus negative 4 is positive 4x. 0 minus negative 2 is plus 2. Now, I'm not sure how your computer, the homework wants it, right? But your quotient is x minus 2. Your remainder is 4x plus 2. And then your divisor is the x squared plus 2x plus 1. Mhm.
You go about that.
This one?
Yeah.
Mhm.
Or X plus 4y. um, different.
Try does not factor.
That- right.
Does not factor.
How
Yeah.
do you know when it does not factor?
If you look at the B term is too small.
So,
Yeah. Should be a larger B term.
that's what we should.
Right. Alright. What you got?
There's one I showed you, I'm not sure if I'm getting it wrong, but it's a to a cube plus a squared b plus ab squared minus 3ab squared plus 3b cubed.
3 what?
3b cubed.
Like that?
And it's multiplied.
This is it?
No, a.
Oh. So nothing here is alike, so you just type it straight into what word?
And against 3ab squared, the squared,
Which one?
the a squared is the.
Mm-hmm. So they're different.
Right, type that.
Hmm? This school look different from this morning. People got red on.
There's parentheses or.
Yeah. Definitely.
That's cool.
Oh, yeah. Go ahead.
On
14. So what's the answer?
7.
X plus 7 and what?
Exponent.
You're close. It's actually X minus 7, X minus 7.
Oh, that's fine.
Correct? They might want X minus 7 raised to the second power. Like this one.
Yeah, same thing.
Is that wrong?
Yeah. Yeah, sometimes they want like a specific answer.
Yeah, that makes sense.
What's that? Good. If they need it, yeah. Sure.
16, correct.
I heard 16x squared.
Minus 8,
Okay,
plus 1.
that's it.
So we 4, minus square,
Now plus 1 squared.
plus square. Four. 16
Sorry.
16 squared.
Mm-hmm.
Minus 56 plus 49 squared.
What's the answer? For what?
For 8.
Mm-hmm.
So 4, yeah,
Mm-hmm. Keep going.
4.
Good. How do I get 49?
7,
7 what? 7b, right? Awesome.
That's it. Good.
Y'all could also be working together if y'all want. Y'all doing the same questions. BC Wi-Fi. So you do click on BCC, and then your login is your first name dot your last name, and then the password to your email. Your email. Yeah.
So, I'll cheat a little bit, but it told me like completely different answer. I'm not sure what they did here. That was different.
Just to expand it.
Yeah, is correct in there.
Okay. You see how you have this a squared b here and a squared b here? Those are the same, so you can add those together. Or it has to be the same type of variables.
I think that was there, wasn't it?
Mhm. So yeah, that's the only difference.
That's correct.
Oh no, they did the multiplication, right? Whatever.
Yeah.
Yeah, it's all good. Yeah. You ready?
That's good. That's correct.
Mm-hmm.
X,
Now 4.
4. X,
Okay. Plus.
4.
In square. That's it. I feel like that doesn't factor. Tell me what happens when you set that.
Oh, it says no.
Yeah, so the answer for that is does not factor.
That's not.
Yeah.
But even when it doesn't,
I just looked at the middle. So I'm thinking about, let's say that it was 4y, x plus 4y. 4y plus 4y is 8y. That's not 4xy.
oh, the young look at the middle.
Yeah, just look at the
You have to
middle.
add up. Oh. 2 more. That's 12.
It has to add up to whatever the factors are. So this could work, maybe. So what would the answer to this be?
6.
Hmm? No,
What?
now we're talking.
That's one.
Mm-hmm.
That's 80.
What's the greatest common factor then? 80, no. What's the number that all three of them can go into evenly? It involve twos. So I see they have what common? Variable. What do they have in common? X. And then what's 32, 80, and 50?
All together?
Like, what do they have in common? So it's okay to not know. You can chop this in two and then see what happens, right? So this is what, 16 x cubed plus 40x plus 50, 25. No. 2x. Yep. You're right. Sorry about that. This would be squared. That one looks a little complicated. I'll just AC method that.
Put that,
This is complicated. AC method this joint. A times C. 16 times 25 over 2. I feel like that's 200. Am I right about that? 8 times 25? Yeah. Mm-hmm.
Yes.
100. All right. And my B is 40. Now, two numbers that multiply to 200 add up to 40. What are they? 10 times 20? True. But 10 times negative 20. Wait, what am I talking about? Hold on. 10 times 20 over here, but 10 plus 20. Sorry about that. That's the 30. That's not gonna work. Give me something else. Oh, 20 times 10, same thing. Give me something else for 200. Like I want, huh? I want two numbers that multiply to 200. Three and what? To 200. 102 does. 50 times 4. I like that. Yeah, that's 200. But 50 plus 4 is 54. Right? I don't even know what school that is, that Burgundy. Looks nice. It's the only school I've ever seen with Burgundy.
Like school, yeah.
Nah, some schools they don't have a facility to graduate in, so they rent out like someplace over here to graduate, like Blue Memorial and stuff. Yeah. It's different. I know EOC graduates over here. Some high schools do. Our GD program does, you know. It's not factorable. That happens.
The piano's gonna leave though.
Really? Lehman is larger. Lehman is larger. Yeah,
They like, what?
it's not that bad. So, hmm? Huh? It's 20, right?
Yeah.
But 10 plus 20 is 30. Yeah, so add to 40 and multiply to 25 over 2. Hmm. Maybe it's not factorable.
That's what got me when I was doing
You said it was right.
the
Put that up back.
This is wrong.
when Tony was doing radicals.
Yeah.
She was giving out numbers, like some big numbers.
Nah.
She just knew all, it's just spitting out numbers. I was like, oh, nah.
What it is to do, yeah.
She just gives.
She is very smart. I mean, move on to another question. You can always come back later. The next section or whatever. Matter of fact, while y'all working, let me get some more water. I'll be back. Everybody graduating.
Ready?
Wait, not yet, not yet. I'm gonna get some water. I'll be right back. But if y'all want to work together on the homework, go ahead. Hold on, see.
No, like all together. Alright. Got like 26. I did like two, got one that's half complete. I got a barely, so I got like 3 done. 100%. Alright. I think like. Every weekend. Prior to watching the video.
Yeah. I mean, over here it's not so bad because this water fountain, you could like, bend over and drink from it. But other buildings, like in CPH, for example, their water fountains, if you don't have a bottle, you can't drink from it. It's like it's designed in such a way to fill a bottle, not for us. All right, go ahead. That's what? Okay.
The divided on
Okay.
X cube minus one X. Square. Plus 24 X. Minus 7. Over X minus
X minus one, you said?
4.
4. So same thing, just use the long division to do it. So you do X minus 4. You have the X cubed minus 9X squared plus the 24X, yeah, minus the 17. So X goes into X cubed how many times? X what? X squared. And X squared times X is, it's X squared times X. Okay. X what? X squared times X1, X cubed, right? All right, and then X squared times negative 4X is what? Oh wait, X squared times negative 4 is what? Not positive. Like positive X squared times negative 4. What is that? No. So positive X squared times negative 4.
Negative.
Negative 4 what? X squared, right? Now remember, this is a polynomial, so what I want to do now, I want to subtract this. It's going to cancel out. Negative 9 minus negative 4 is what?
5.
Negative 5. X squared, bring down to 24. This is positive 24X, right? So now X goes into negative 5X squared how many times? Yeah. What here? Or -5 what? Like just this part here, the -5x². Right? No, I'm trying to divide it. I wanna know how many times x goes into -5x². No. So I'm asking you this, -5x² divided by x. That's what I'm asking.
That's,
What is it? No, -5 what? Good. Then now, -5x times x is -5x². -5x times -4, right? That's gonna be what? See it? Yeah, got you. So -5x times -4 is what? Negative is a positive 20x, right? And then we're gonna subtract this. Um, mhm. -17, sorry. Oops. X goes into 4x how many times? 4 times. 4 times x is 4x. 4 times -4 is what? -16? Hmm? So now you subtract it, right? You subtract out -17 minus -16 is what? -1. So the quotient is the top. That's the x² minus 5x plus 4. Yeah, and then the remainder is -1. 5x?
There's gonna be x3 minus 3x. That's the-
-1, -1.
-1.
All right. My fault. Go ahead. Say it again.
x3 -3x plus 3x
Like all of it?
to the power minus -2x positive.
X to what power? Oh, x². Oh, what was this? What was the rest of it?
-2x
Mm-hmm.
positive.
So you love division, right?
Exactly.
Okay. So x² minus 20.
Hmm?
Yeah.
So
X, divided X.
mhm.
No,
They got two x².
yeah,
Hold on. Over here, x times a -2x, -2x². Oh, hold on. That's supposed to be x³ right here, right?
Yeah.
First one, my fault. Yeah.
like minus.
So you taking this term and you distributing it to everybody, and then you're gonna put them out here as the answer. So that's the negative 2x squared. X times 2 is what? 2x. Subtract these. Hmm? So x cubed and x cubed will cancel out. Negative 3x squared minus negative 2. Yeah. Yeah. Minus 2x squared. What's the answer? Not quite. Oh yeah, well, like 1x squared. Yeah. You're right. X plus 2 plus 8. And then bring down the plus 5. Yep. What's next? So it goes in positive 1 time. X squared minus 2x plus 2. I'm subtracting here. Oh wait, plus 2. No, you're right. Plus 2. You're right. X squared and x squared cancels out. 8 minus negative 2 is what? No. 8 minus negative 2 is? No. 8 minus negative 2. What's that? So what is it? 10x. Sorry about that. Prank calls all day. 10x. And then 5 minus 2. What's that? No, what's 5 minus 2? 3, right? That's going to be plus 3. Right? Hang on 1 second. Yeah. So now that's our remainder basically. So we have x plus 1 is your quotient, 10x plus 3, that's your remainder. What's wrong? Not sure how they want to enter though. That's the only question. Let's see what I can do. Wait. Made a boo-boo. All right, let's try it again. So negative 3 minus negative x squared, that's negative x squared. 6 minus 2x is plus 4x. Right? And then bring down that 5. And then now x squared goes into negative x squared negative 1 time. What's 3? What'd I do? Because it's negative 3 minus negative 2. Right? So that becomes like the negative 1, boom. And then we multiply this out. It's going to be negative x squared plus 2x and then minus 2. Then we're going to subtract that. So negative x squared minus negative x squared is negative 2x squared. Wait, no. What am I talking about? This is going to cancel out. 4x minus 2x is 2x. 5 minus negative 2 is what? No. No. 5 minus 2. So 5 minus -2.
Okay, I think it's right.
What is that? 7, right? Now we're talking. So quotient x minus 1, remainder 2x plus 7. Got it? Quotient's wrong? Let's see. Ba, 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 ba. I don't know, it looks good to me. It's right? Alright. Alright, go ahead. Okay.
Plus 2 minus 8x squared. 7x minus 4 over 2x squared plus 5. So we do long division, right?
Right.
2x squared plus 2x
Mm-hmm.
equal x 4.
Right.
Subtract, so it's 2.
Sorry. Plus 7x minus 12. Okay.
Was x over
X, very good.
2x2 plus.
Okay.
You got 5x. Yeah, yeah.
Oh, we're good. So that's 5x.
Yeah, yeah.
I just put it there as a placeholder. It didn't have to go there, you know? Okay. X times 2x squared, this cancels out. X times 5 is a 5x. We're gonna subtract that, so -8 minus 0, -8x squared, right? 7 minus 5 is what? 2. X, bring down to -12. So now 2x squared and -8x squared, what is that? What do I multiply that by to get that?
2x squared
Times what?
divided 2x.
Right. So I'm looking for -8 divided by 2. What's that?
4.
Close.
Negative 1.
-4, right? So this is -4. -4 times 2x squared. This is going to be a -8x squared. And then -4 times 5 is what?
Negative 1.
Say it again.
Negative 1.
So that's -20. I'm just going to add a 0x right here just for a placeholder. Subtract this. These cancel out. 2x minus 0 is -12 minus -20. Positive or negative. And that's it. That's the quotient is the top number, the remainder is the bottom number.
Right.
Yeah.
thought there was.
Mhm.
Yes,
There is?
yeah, well, apps, so you can download, so like when you're offline, you can,
That must be a huge download.
not just a gigabyte, just for you.
That's a lot, no?
I don't know, I
A
got.
whole gig.
Great.
Yeah. Alright. Y'all don't have anything different though? It's the same questions?
It does look like it's the same
Yeah.
question.
Yeah.
I just want back. It's just like
Yeah.
the following problem. Unless you did it. 3x cubed
Okay.
divided 2x squared.
Mm-hmm.
Oh shit, but it's for like a whole year.
Positive
Mm-hmm. Yeah, it's my big.
negative 23
Like that?
divided by two x squared. Positive
Okay. And what is this? 3x cubed minus 2x squared plus 7x minus 23. Okay. So help me out.
Oh, wait, we put 3x.
What do you mean?
2
Wait, what did I do wrong?
3x
Uh-huh.
is 2x.
Like this is 2x cubed, you mean? Okay.
12
Oh, and this is 12x squared? Okay.
yeah.
Okay. All right. So 2x squared goes into 2x cubed how many times? 1x times, right? X times 2x squared is what?
2x.
Right? Subtract. Oh, my fault. And x times 5, of course, is what? 5x, right?
So why don't you talk,
I'm sorry?
why don't you talk it?
Divide by negative
Why don't
2x?
you talk it?
Because it's not the same thing. Yeah, they got to be the same like terms.
Okay.
Yeah, it's the like terms that's doing it. So 2x cubed minus 2x cubed cancels out. Negative 2 minus 0 is what? Negative 2 x squared. 7x minus 5x is,
No. So,
oh, my fault. All right, so negative 12x squared. All right, and then 7x minus 5x is what? 2x. Right, so that's plus 2x. Now, 2x squared goes into negative 12x squared how many times?
2x divided 2.
Negative 12x squared how many times? Negative 6 times, right? So negative 6 times 2, that's negative 12x squared. Negative 6 times 5, that's what, 25, 30? So that's negative 30. Negative 10, negative 6, yeah. And I'm just gonna put a 0x right here. Gonna subtract these. Oh, I forgot to bring down negative 23. So now what do I have? These cancel out. 2 minus 0, just 2x. Negative 23 minus negative 30. What's that, plus 7? And that's it. Nothing else you could do. The top is your quotient, bottom is your remainder. Is it the same thing or you got something different? Once y'all get the processor ready, it ain't changing from question to question. So do it.
Alright, X cubed.
Nah, do it on your own.
Alright.
It's the same thing. All right. Nah, we'll do that later. Let's look at today's lesson. Yeah. All right, so look, what we're gonna do today, we're gonna do something called polynomial equations. It's a real short lesson because y'all know how to do it all already. I'll be honest. Right? So what is a polynomial equation? A polynomial equation is an equation that contains a polynomial expression. The degree of the polynomial equation is the degree of the polynomial. Right? Long story short, everything that we've been doing are expressions. Now we're gonna set them equal to 0 and we're gonna get an answer. That's it. The same work, the same process, right? So expressions, they don't have an equal sign. And I'm not looking for a straight up answer like x equals whatever, right? Equations have equal signs, right? So I'm looking for an actual answer for x, for example. So let me just show you what I'm talking about. Right? So we are now going to solve polynomial equations of degree 2. A polynomial equation of degree 2 is called a quadratic equation, right? And here's an example of some below, right? So you have like x squared plus 5x plus 6 equal to 0, or 3y squared plus 4y is equal to 10, or 64u squared minus 81 equals 0, or n times n plus 1 is equal to 42, all right? Just showing you some examples real quick. Let's talk about the quadratic equation. So quadratic equation is an equation of the form ax squared plus bx plus c is equal to 0. This is called a quadratic equation. A, b, and c are real numbers and a cannot equal 0. That's important right there, all right?
This is my last lesson last time.
It was?
Yeah.
Nice.
This and trigonometry.
Oh yeah, that's coming. Well, we got a couple more weeks before that. All right. So now let me talk to you about a really dope property. This is called the zero product property, right? So let's say that we have two numbers. I'm just gonna call them A and B, right? So if A times B is equal to 0, then either A must be 0 or B must be 0, or both of them are 0, right? Because we all know that the only way to get 0 out as an answer through multiplication is if one of the numbers is 0, right? Zero product property. And we're gonna use that to solve quadratic equations. Let's take a look. All right, pay attention. This part is real hard. Wait, that's not it. Oops. My mistake. Try that again.
The zero product property.
Yeah.
The hardest part.
Yeah, this one is mad hard. I'm not gonna lie. This is like bringing back vibes from the beginning that we did, right? So I want to solve this equation right here, right? So here's how I solve it. Just gonna give y'all my method. Hold on, I need a pen. Hold on. I always forget my pen. No, bad student. Okay. So what I'm gonna do is I'm gonna set each one of these individually equal to 0. Then I'm gonna solve for the variable. So real quick, I have 5n minus 2 is equal to 0. Solve for n. So what do I do? All right, I'm gonna add 2 over here. Where I do the one side, do to the other. So I have 5n is equal to 2. Divide by 5. Where I do the one side, gotta do to the other. Right? So, right? That's it. N1 is equal to 2 over 5. And then for the other one, I have 6n minus 1 is equal to 0, right?
Add one.
Mm-hmm. What you want to add the other?
And divide by.
Uh-huh. So divide by 6. Yeah. So N2 is equal to 1 over 6.
So the basic algorithm.
Yeah, that's it.
Okay.
So then.
For the second part.
Well, you're gonna go to a part where you don't want it as a fraction.
Oh no, you can leave it like this.
So it could be
Yeah.
school.
Yeah, I'm chilling. Yeah. Like you mean with decimals? Like I'm straight. Yeah. Yeah. To a decimal. There you go. Too complicated. This is hard enough as it is. You guys try.
This.
Mhm.
Zero point five will be 1/2.
Mm. Yeah, it is. Yeah, it is.
For both sides, you can put equal sign up here.
I put an equal sign on both sides. Yeah.
Oh,
So let's try this one out. I like to partition these two right here. I'm gonna. Mm-hmm.
Plus two.
All right, so plus 2. Good.
Divide by three.
Exactly.
And minus two.
Exactly.
it
And
should be
then-
everything. Next step.
Mhm.
Just this. The hardest.
I mean, it is low key. I mean, I don't even know if I'm gonna be even asking y'all some of the stuff that we did earlier. I'm gonna just probably ask you these questions. To be honest, it'll be there, but in this form. So subtract 1, subtract 1. 2m is equal to -1. Divide by 2. Divide by 2. You don't know. Yep.
Oh, negative.
Yeah.
Oh,
Is any questions on this? Make sense? -1/2. Yeah. 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 Yeah.
so you just keep it like that every time, or else if I apply, just keep it for you know,
Mm-hmm.
every single time.
Every single time, same thing. Let's take it up a notch, right? So we want to solve quadratic equations by factoring. So the zero product property works very nicely to solve quadratic equations. The quadratic equation must be factored with zero isolated on one side. So we must be sure to start with the quadratic equation in standard form. What standard form? Ax squared plus bx plus c is equal to 0. Then we must factor the expression on the left. All right? Let's take a look. Let's say I want to solve this. Right? First thing I got to do, put it in standard form. Right? So how do I do that? Move everything over to the other side. I'm going to subtract 13y from over here. What I do to one side, I got to do to the other. So now I have 2y squared minus 13y is equal to 45. And then I'm going to subtract 45 from over here. What I do to one side, I got to do to the other. So now what do I have? I have 2y squared minus 13y minus 45 is equal to 0. Right? After that, all I need to do, I just need to factor this. Right? How do we factor this again? 3 terms. What do I use? AC method.
Oh.
Right? So what's the AC method again? A times C, 2 times negative 45. Should give me, what's that, negative 90? And then my B is equal to negative 13. Now I need 2 numbers, and when I multiply it, will give me a negative 90, but when I add them together, it will give me a negative 13. What are they? 7 and 3? 10 and 3? Like 30? 10 times 3? What do you mean 10 times 9? 10 and 9, negative 90 and negative 13. So first off, look, we have negative 90. So what does that mean? That means that one of the numbers has to be negative, one has to be positive. The larger one is going to be the negative because our B term is negative. Right? 15 times what? Let me see. 30, 60, 90. Yeah, times 6. So negative 15 times 9. Negative 90. Negative 15 plus 9. Whoops, 6. What's what am I talking about? That's negative 9. Something like that. Yeah. So what else we got? Easy way to do this, use a tree.
Oh, the factor.
Yeah. You know, this is 9, this is 10. Right? Hold on, where's my mouse? Where's my mouse? Okay.
3, right?
This is 2, 5, and 3 and 3, right? Whatever I'm looking for is going to be some combination of these 4 numbers right here. Right? So 15 and 6 was good, but that didn't give us our negative 13.
7, 6.
7?
7 to 6.
How'd you get 7?
Let's just add the follow back.
No. Multiplication.
Also 5 times 3.
Mm-hmm.
It is.
Something like that, yeah. Mm, that's it. 18 and 5. 3 times 3 times 2. That's the 18 and then the 5.
Oh, you just multiply it together?
Yeah. So what I'm doing in my head is like I'm like say multiplying these three together and see what happens. And then I'm like, okay, let me see if I multiply these two and the other two together, you know? Like that's how you play with this to get your final answer. But yeah, negative 18 times 5, negative 90, negative 18 plus 5, right? That's the negative 13. Beautiful. So you already know what we're gonna do, right? I have 2y squared. All right. I'm gonna rewrite this. All right, get home safe, man. Catch up with you. Minus 18y plus 5y. And the last number minus 45 equals 0. It doesn't matter the order that you put the middle numbers in. I'm just putting in that order because that's the way I heard it, right? But if you want to reverse it and say 5y and negative 18, that's fine. Right? Yep. And then you partition it just like that, right? You remember factor by grouping. So I have on my left hand group, I have 2y squared minus 18y. What's the greatest common factor there? No. 2y. Good, good, good. 2y. And what does that leave over? Remember, it's like I'm divided by 2y. Like I'm dividing by 2y. What is that? Hmm? No, y minus 9. Very good. Okay, I'm looking at this the right hand group now, right? So the 5y minus 45. What's the greatest common factor there? 5, right? So plus 5. Remember, it's like I'm dividing by 5. Like I'm dividing by 5, right? So I'm gonna have what? Y minus 9. Very good. And of course, it still equals 0, right? Greatest common factor again. What do I have? I have y minus 9 times 2y plus 5 equals 0. Here's our next step, right? Partition these, set them equal to 0. Y minus 9 equals 0, right? Add 9 to both sides. So y1 is equal to 9. Over here, 2y plus 5 is equal to 0. Subtract 5, what you do to one side, you do to the other. So you have 2y is equal to negative 5. Divide by 2, divide by 2. Right? So now I have y2 is equal to negative 5 over 2. All right? Questions on this? Yep.
Why is it not Y?
Why is it not y? What do you mean?
So why two?
Yeah, like I mean, when I say y2, I mean the second y. Because there's two answers for this question. Remember, when you have a quadratic, you always have two answers. All right. Questions on this? We good? All right, you guys try. Hmm? I mean, but you could low-key use this on your homework for yesterday too. It's the same topic. It's just that we're solving for an answer now. All right, let's take a look. So remember, the goal here is I want to solve for C, right? So I want to put everything in standard form first. So I'm going to subtract 10C. See, I always do that. I always forget my pen. Always have, I'm gonna do blue now. I'm gonna subtract 10C from over here, but what I do to one side of the equation, I have to do to the other side of the equation. So I'm gonna subtract 10C from over here. So now what do I have? I have 3C squared, is equal to, exactly. Now I wanna add 8 to both sides, right? Because I wanna get this in standard form.
So it's 3C minus 2 plus
3C squared minus 10C plus 8 is equal to 0,
0.
right? All right, so now that we have that, let's factor this. I have 1, 2, 3 terms here. What's my favorite method to use? AC method, right? So 8 times C is equal to 3 times 8, which I heard 24, good. And B is equal to -10. So I need two numbers that multiply to 24, but add up to -10. What are they?
So positive and two.
No, but that would be -24. So I need, right, they're gonna both be negative, right? So negative something and negative something. So, but -12 plus -2, or whatever, yeah, -12 plus -2, that's gonna be -14. So it can't be that.
Then it'd be 6.
Yes. So -6 times -4, that's positive 24. And -6 plus -4, that's the -10, right? So now you already know what we're gonna do. We're gonna rewrite this equation. So I'm gonna have 3C squared minus 6x minus 4x plus 8 is equal to 0. Again, it doesn't matter what you do in the middle, right? If you said, oh wow, where did x come from? That's supposed to be c's. If you said 3C squared minus 4C minus 6C plus 8, you will get the same answer. It doesn't matter the order that the middle part is in, right? Let's partition these, right? I want to group them, right? So I have a left group and I have a right group. On my left group, I have 3C squared minus 6C, right? What's my greatest common factor there? 3C, excellent, right? And what's left over? C, and what else? C minus 2, that's excellent. All right, I'm looking at the right-hand group now. This is the -4C plus 8. What's the greatest common factor there? Say it again. Close, close. Give me something better. -4, now we're talking, right? I want to know what the greatest common factor of the second group is, right? So, and how do I know it's negative? Because the sign of my leading coefficient is the sign of my factor, right? Sign of my leading coefficient is the sign of my factor. So anyway, factoring out -4, right? So -4 cancels out, leaving back just C. And what is a positive divided by a negative? That's a what? Negative. And 8 divided by 4 is 2. Of course, it's still equal to 0. Greatest common factor. So I'm going to have C minus 2 times 3C minus 4. All right. So now we're almost done, almost done. Set both of these individually equal to 0. So C minus 2 is equal to 0. 3C minus 4 is equal to 0. And we just solve for C. So I'm going to add 2 over here. What I do to one side, do to the other. So C is equal to +2. We'll call that C1. And then +4, +4. So I have 3C is equal to 4. Divide by 3. Right? C2 is equal to 4/3. Very good. Questions on this? Go ahead. C squared? Where? Say it again? No, like C2. Like I'm naming it. Like C1, C2. What's your question? Oh, okay. Good? You multiply A times C, yeah. You find, you have the B term. So you find two numbers that will give you what A times C is, but they have to add up to what the B term is. Yikes. Help me out, how I do this? So how do we think I'm gonna do this? Not divided, but go ahead. Exactly. That's step one. I'm gonna move the. No, step one is I'm gonna get a pen. That's what I'm gonna do first. All right, step two, I'm gonna move the 49 over from one side to the other. So now I have 169 Q squared minus 49 is equal to 0. All right, help me out. What's the answer? Yeah, what's 169? Not 169. What times what is 169?
Oh,
13. 13 what? Q, no, not square. Q what? And this is 13Q over here. 13 times 13, 169. Yeah, yeah, yeah. So -7. And what's the other one? +7. Right? Difference of two perfect squares, right? Same game as before. So I have 13Q minus 7 is equal to 0. Add 7, add 7. And I have 13Q is equal to 7. I'm going to divide by 13. When I do the one side, do to the other. All right? So I have Q is equal to 7 over 13. Over here we have 13Q plus 7 is equal to 0. I'm going to subtract 7 when I do the one side, do to the other. So I have 13Q is equal to -7. I'm going to divide by 13 when I do the one side, do to the other. So I have Q, let's call that 2, is equal to -7 over 13. So when you see me use Q1 and Q2 or whatever, right? Those little numbers on the side, it's just a name. Doesn't mean square, it's just a name. That's all it is. Nah, just a name, yeah. Questions on this? It's easy? You guys try. All right, let's try this out. What am I gonna do first? Oh, I'm gonna grab my pen first. But every time I forget, matter of fact, I'm doing right. All right, so subtract 49, very good. If I do to one side, I gotta do to the other. Very good. All right, yes, please.
Five. Plus,
What's the other one? Excellent, well done. Yep, so 5p plus 7 is equal to 0, and 5p minus 7. Awesome. Mm-hmm. Mm-hmm. -7. Mm-hmm. All right. Other side, I'm gonna add 7. So I have 5p is equal to 7. Oops. Oh. Let's try that again. I'm sorry. There we go. And then I wanna divide by 4. Yeah, like, you mean next to the 7, you mean?
Yeah.
That's fine, yeah. Yeah. Questions on this? No matter. Everybody's getting this though? Any questions? Good? Okay. Let's try this one now. What's tomorrow? Wednesday? Gotcha. Oh, yo, you guys know that today's election day? Yeah. Right, yeah, for Congress. Yeah. I mean, depending on where you live, you're like, nobody's the same. It's like a Congress thing. Oh, you know what, before I forget, quick, before we even get into this. So, remember how earlier in the semester I was telling y'all about pantry and stuff like that?
Yeah.
You get groceries and stuff, so that's tomorrow. Just letting y'all know. Alright? So, it's between 10 a.m. and 5 p.m. Alright? So just go over to the little hall, get your groceries, you know, the admissions building. No, this way in the front, where the stairs are when you come on campus, right? So just go there, go downstairs, get your groceries, bring them home, whatever, you know, for free. Yeah. Just remember that ARC form though that I showed you? Just make sure you fill that out before you go though, like, all right, then you'd be good to go. Yo, bring a cart, bring something, bring a car, whatever, like it's, yeah. Yeah, it's like they really bless you. It's not like a can of beans and that's it. Like, you know, like groceries, like a good like $200 worth of groceries. Like it's a lot. Yeah. I mean, like they also like kind of interview you a little bit, you know. So if you someone that has like a family or something, like obviously you're gonna get more, you know, than someone who's just by themselves, you know. Yeah. Yeah. I mean, it's not like cooked food though. It's like groceries, so it's like mac and cheese in a box kind of thing, and you still got to cook it, you kind of thing. Yeah, yeah, yeah. And they have like fresh fruits, fresh vegetables, all of that. They have canned ones too. I'm not sure. Not sure. Like that's mango is funny though, because that's like a seasonal kind of thing, you know. Yeah. Yeah. All right. So can't say I ain't tell y'all. Do you need to see where to get the art form or are you good? I'll do it at the end. I'll do it at the end. I'll show you. Yeah. No. Just once you fill out that art form, you go in and they're gonna be like, oh, what's your ample ID or show them your ID and that's it. It's real quick, real quick. All right, so let's get into this real quick, right? So I want to solve this equation, but I can't just solve it the way it is, right? First thing I gotta do is I gotta distribute. That's my first step. I gotta distribute over here, right? So 3x times x, that's gonna give me what, right? 3x squared, very good. 3x times -1. Oh, 3x times -1.
Oh, okay.
Negative 3x, very good. And then now I have, erase that. -8 times x, what's that? -8x, right? And then lastly, I have -8 times -1 is what? +8, very good. And then that's equal to 3x, right? So what do I want to do now? I want to combine like terms, right? Combine like terms. So I have 3x squared minus what? 11x plus 8, right? Is equal to 3x. Now again, I want to put everything in standard form. So what am I going to do? I'm going to subtract 3x from over here. But what I do to one side of the equation, I have to do to the other side of the equation. I'm going to subtract 3x from over here. So now, what do I have in total? I have 3x squared minus, what's that, 14? X plus 8 is equal to 0. What am I going to do here? You already know. AC method, right? So let's try it out. I have A times C is equal to 3 times 8, which is what? 24, right? And then my B term is equal to -14. So now I need two numbers that when I multiply them will give me a positive 24, but when I add them together, give me a -14. Right off the bat, I can tell you both numbers will be negative. And how do I know that? Because the only way to get a positive number through multiplication is if both numbers are positive or both numbers are negative, right? So that being said, help me out. You better get this. Yeah, you better get this.
That's what I was saying, right?
Yeah, exactly. You better get this.
-12.
Uh-huh. All right, very good. So that's 24, right? Then we got -12 plus -2, that's the -14. All right? So you already know what I'm gonna do, right? I'm gonna rewrite what we have, right? So I have 3x squared, but instead of the -14x, I'm just gonna plug in what I got. So I got -12x minus 2x plus 8 is equal to 0, right? And then I have 1, 2, 3, 4 terms right here. So you already know. I'm gonna group these together. For my left-hand group over here, I have 3x squared minus 12x. What's the greatest common factor there? 3x, very good. And what's left over? X what? Minus 4, very good, very good. All right, so now I'm looking at the right-hand group. This is the -2x plus 8. What's the greatest common factor there? Close. Give me something better. -2. Now we're talking, right? And why is that? It's because the sign of my leading term is going to be the sign of my factor, right? Always. Let's continue. So I'm factoring out a -2. It's like I'm dividing by -2, like I'm dividing by -2. So -2 divided by -2 is going to leave back x. Very good. And then 8, right? -4. Very good. That's going to be equal to 0. All right, let's do this one more time. Greatest common factor is going to be x minus 4. And what's left over? 3x minus 2. And then that's going to be equal to 0, just like that. So now what do I want to do after that? I want to set both of these equal to 0. So I have x minus 4 is equal to 0, and I have 3x minus 2 is equal to 0. Then just solve for x. On the left-hand side, I'm going to add 4. Where I do to one side, you know I got to do to the other. So I have x is equal to 4. That's one answer. And then on the right-hand side, I'm going to add 2 over here. What I do to one side, I got to do to the other. So now I have 3x is equal to 2. I'm going to divide by 3. What I do to one side, do to the other. So I have x, let's call that 2, is equal to 2 over 3. All right. Those are my answers. Any questions on this? And it's okay to ask, no problem. Yeah, yeah, yeah. These are kind of long. Go ahead. What was your question? Yeah, that was step one right there. We had to foil it out. Say it again. If we no, I didn't have the 3x and the 8x, so I had to foil first to get that. Yeah, but I did combine it though. The negative 3x minus the 8x, that's how I got the negative 11x. But my next issue was that 3x on the outside. I had to put that in there to get it in standard form. Like up here? We can't though, because it'd be multiplied. It's like a binomial times a binomial, so we have to distribute and all that. Yeah. Yeah, but this is like the trickiest that your work will be. It's like this type of question right here. Everything else is real smooth, real nice. Sure, sure. Tell me when to stop. All the way? So that's the final answer right there. You good? So I keep forgetting what tomorrow is. So Wednesday, tomorrow is 1 to 4. Yeah. And then Thursday is gonna be online before class. Then we'll have class. Good? You guys try. So I'm thinking this next set of homework, let's get it done by like Thursday next week. Yeah. Yo, as for the test, I'm gonna ask y'all for just one more day. Just have like one test to grade real quick, and then I'll give it back to y'all tomorrow. Yeah. No, I'm gonna give it back to you. One that you took. Yeah. I mean, it's not so bad. Like I said, like one person got a 0, so pretty much everybody in here got better than that person. Yeah. I mean, not everybody passed, but everybody got better than 0. It happens. No, 6. Yeah. Yeah. 3 and 4. Oh, you mean my thing? Yeah. So the reason why I'm like finishing so early in tutoring is because like time to walk over kind of situation. Like if they did open me up like from 5 to 6, like it'd be real bad. I'd be walking out on people in the middle of the session, to come here. So no problem. All right, let's go over it. So problem here, can't answer this the way it is. So I have to distribute it, put it all together, bring the 12 over, and then we'll get our answer. So first thing we want to do, we got the 2m times m. What's that?
So square.
Very good. All right. Plus 6m. Very good. All right. Plus 1m. Plus 3. Very good. And that's all equal to 12m. Right? We want to combine like terms. So, 2m squared plus 7m, right? Plus 3 is equal to 12m. What do I do after that? Subtract, no, 12m, right? Standard form. And we're going to subtract 12m. Go ahead.
Moving the.
No, you're just adding them. No, you just add them with 6 plus 1. Yeah. But yeah, this middle part is going to turn negative now. So 2m squared, 5m, very good. Plus 3 is equal to 0. All right. So now that I have this, right, I want to factor this. AC method, right? A times C. What up? I just feel like rainbow right now. A times C is going to equal to what? 2 times 3, which I heard was 6. Very good. And my B term is what? Negative 5. All right, so now look, I want two numbers, so when I multiply them together, will give me a positive 6, but when I add them together, will give me a negative 5. What are they? Let's see, so 6 times negative 1, that's negative 6. Wait, that doesn't work. Give me something else. Okay, so let's look. 2 times 3, right? That is 6. 2 plus 3, that's 5, but I want negative 5.
So, yeah, your.
Negative 2 times negative 3, let's see, that is positive 6. Negative 2 plus negative 3, that's negative 5. Excellent. All right. So you already know what we're going to do. Let's rewrite this. I have, 1 second. Microsoft, what you doing? All right. Microsoft, what you doing? Come on. Yo, you wilding right now. It's like frozen for a second. Give me 1 second. I know this thing just didn't close on me, but sorry about that, you guys. Apologize. Technology be against me sometimes, you know? AI is cool. Yeah. A lot of my Google search has been AI of lately, I noticed. You know? Yeah. Yeah. So it's like what it does. And I don't know if this is a good thing or a bad thing, but it's like what it does is like it'll scan the website for whatever it is I'm looking for, and it'll just tell me in Google. So it's like when I search for things now, like I'm not actually leaving Google's page. Like I'll just get my answer in Google and then I'm out, kind of thing. Yeah. I don't know if you guys noticed that, but I've noticed that with me. You know? It is, yeah. It kind of sucks though for the people that paid money to get their websites up and running and all of that, right? Because I ain't visiting it no more, you know. I get my answer and I'm out. It is what it is. Oh Lord, what's happening here? All right, we good. All right, anyway, you guys know what I'm gonna do next, right? I'm gonna rewrite what I have. I didn't expect that, but okay, whatever. We have 2m squared. Instead of the negative 5m, I'm going to write down what I have. I have negative 2m minus 3m plus 3 is equal to 0. Right? Just like that. And then what am I going to do after that? I'm going to partition this, right? I'm going to group the first two terms, group the last two terms. So in the first group, right, which is the left-hand side, that's a 2m squared minus 2m. What's my greatest common factor there? 2m, right? So remember, it's like I'm dividing by 2m. It's like I'm dividing by 2m, right? What's left over? No. So 2 and 2 cancels out. This is m in the square will cancel, leaving back just m. And then a negative divided by a positive is a negative. And 2m divided by 2m is 1, right? Anything divided by itself is 1. What's the greatest common factor of the second group? Close. Give me something better. Negative 3, right? And why is that? It's because the sign of my leading term is going to be the same sign as my factor. Always. Right? So I have negative 3. Remember, it's like I'm dividing by negative 3. Like I'm dividing by negative 3. What's left over? Well, negative 3 cancels out. M, very good. A positive divided by a negative is a negative, and 3 divided by 3 is 1. Excellent. It's equals 0, right? Greatest common factor. I'm going to factor out the m minus 1. And what am I left with? I'm left with 2m minus 3 is equal to 0, right? After this, what do I want to do? I want to set both of these individually equal to 0. So I have m minus 1 equals 0, and 2m minus 3 is equal to 0. And just solve for m. I'm going to add 1 over here where I do to one side, do to the other. So I have m is equal to 1. I'm going to add 3 over here where I do to one side, do to the other. So I have 2m is equal to 3. After that, I'm going to divide by 2 to get m by itself. Right? So we have the second m, m2, is equal to 3 over 2. And that's it. That's my answers right there. So we must have that. All right. All right, real quick, before y'all go, let me just give y'all a little bit of notes real quick. Just a little sprinkle. Nothing crazy. But you guys get the gist of this, right? We use the AC method or whatever, and then we just setting it equal to 0. And we're gonna solve for it. All right. So I'm gonna give y'all just a little how-to. So how to factor terms, excuse me, how to factor trinomials of the form ax squared plus bx plus c using the AC method. Step 1, factor any greatest common factor out, right? Always look for the greatest common factor first. Step 2, find the product of a times c. Step 3, find two numbers, m and n, such that they multiply to a times c and add up to b, right? So m times n has to be equal to a times c, m plus n has to be equal to b, and then you have the ax squared plus bx plus c, rewrite it as ax squared plus mx plus nx plus c, factor by grouping, and then check by multiplying the factors, right? And that's it. That's how we do this section, all right? The only thing I didn't get to show you guys was a question that involved finding the GCF first. That was going to be my next example. You know, if you guys want, I could run through that, and then you guys can watch it in the video if y'all have to leave. All right. All right, so just one example real quick, and then you should be good with your homework. It shouldn't be too bad. Actually, you know what? Hold up 1 second. Like that. we'll do another. So let's take a look at this, right? I have 9m to the third power, 9m cubed, plus 100m is equal to 60m squared, right? So you already know the first thing I want to do, I want to put this in standard form. Nope, the first thing I want to do is get a pen. All right, but now I want to put this in standard form, right? So I'm going to subtract m squared from over here. What I do to one side, I got to do to the other. Subtract 60m squared. Let's put this all together, all right? They're all different terms. Let me just scroll down a little bit. So I have 9m cubed minus 60m squared plus 100m is equal to 0. All right. What do they have in common here? M. I like that. I like that. What else do they have in common?
So,
Let's see. I guess nothing else, right? All right. So they have M in common, right? So let's factor that out. So what do I have left now? I have 9m squared minus 60m plus 100 is equal to 0. Right? Now, technically AC method, blah, 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 but I know that you guys are pressed for time real quick, so I'm just gonna use a shortcut on here, right? We have two perfect square trinomials here, right? I'm sorry. We have a perfect square trinomial here, right? So you already know what this is gonna become, right? Tell me. Three M. So minus what? 10. And what's the other one? No, minus 10. Right? Yeah. Right? The only time it's minus and plus is when we have the difference of two perfect squares. Right? But in a perfect square trinomial, they're the same. It's either minus minus or plus plus. All right. After we do that now, this is a really interesting situation I want you to take a look at, right? I have m times 3m minus 10 times 3m minus 10 is equal to 0. I have 3 answers here, right? Because it's to the third power, 3 answers. Set all of them equal to 0. So the first one, m is equal to 0. That's the answer. I'm done. The next one, 3m minus 10 is equal to 0, right? Add 10. You do to one side, you do to the other. 3m is equal to 10. Divide by 3. What you do to one side, do to the other. So I have m2 is equal to 10 over 3, right? That's the answer right here. And over here, we have 3m minus 10 is equal to 0. I'm going to add 10 over here. And what you do to one side, you know you got to do to the other. So I have 3m is equal to 10. Divide by 3. What we do to one side, do to the other. m3 is equal to 10 over 3. So the reason why, right, is because we have a multiplicity of 3, right? See, well, technically 10 over 3 is multiplicity 2. But really, this is all stemming from this third power right here. I have 3 answers, right? So I'm just showing you this in case you get this on your homework, right? Where there's going to be like 3 different answers. This is what's happening. So long story short, when you're doing the greatest common factor, and the greatest common factor is a variable, like it is in this case, right? That variable matters in your answer, right? That's a third answer right there. Like that's the main thing I wanted to show you regards to this. Sometimes you might do the greatest common factor and it's a number. In that case, it's not an answer. It's just a separate thing. Go ahead. Mhm. Go ahead. So I was using a trick when I did that. Yeah, but you can use the AC method, man. No sign it, you good. Yeah. I mean, if you want, I could run through it with the AC method if you want to see. But the trick that I'm using, this is called a perfect square trinomial. So what that means is that the ax squared term, which is nine, see man, which is 9m squared, that's a perfect square. And then the c term, which is a number by itself, that's a perfect square also. So when I have that kind of situation, I can do this type of factoring, right? Where it's going to be the same thing, right? It's just that's either going to be like minus minus or plus and plus. How do I know if it's minus and minus, right? I look at the b term, right? If the b is negative, then both of these are going to be negative. If the b was positive, then both of them would have been positive. All right, I'll see you, man. All right. And I'll get you tomorrow with the, oh yeah. I'm gonna get you tomorrow with the what you call it. Yeah, the test. Yeah.
Sure.
All right, I got you. Wait, is everybody done copying? Can I? Thank you. Just bear with me 1 second, real quick. Let me just have a good night, y'all.